Okay, so I'm Kiran from Crypto Econ, and I'll talk a little bit about baseline. I think this will be like a very light crypto econ session and not much controversy. So I'm looking for. Okay, so just logistically.
Are you allowed to be recorded for your session?
No, this session is fine, but we were thinking. Sorry, I just had a chat with Jennifer on this. Like, I think we have to be out of this room by 6, if that's correct, but there was going to be another discussion, and so we might have to find a room for it. We can figure it out. I'll keep going. Okay. So let's talk about baseline. So outline for today, I'll recap. I'll try to give everyone context on the baseline function, what it's for. And the idea here is to just think about or discuss as a group how we might, if we want to change the baseline, what should we be thinking about? So what is the history of the baseline function? It was developed as a way to tie minting to hardware resources that were connected and committed to the network. So it was a nice way to bootstrap the network. And you might ask, how did they decide what the growth rate of the baseline function should be? And that was based on Kreider's law, which is an observation that disk density, there's some conditions on this, but it doubles every 13 months. So the baseline function doubles every 12 months. That's how it was set up. So the first question I have in terms of setting context is, has Kreider's law held up in terms of our observational data today? And so the answer to that, I think there's a general consensus that it hasn't. And I'm getting we can talk about that.
It's a different media type.
Yeah, for sure. Yeah, that's why it's conditioned on a lot of different things. But okay, so that point may not be valid, but
Explain why. Sorry.
Oh,
That's
yeah.
Who does not know what Kreider's law is, and
Oh.
I'm literally hearing about it for the first time. What is it? In what context? Like, do you have any of the data? And like, obviously, I guess in our context, we right now care about Kreider's law as applied to hard drives and the sort of storage.
Yeah. I could certainly talk about Kreider's law at a very high level. I'm not an expert, but I think the point I want to make is that Kreider's law was used in order to say this is how fast the baseline function should grow. And one of the questions I want to ask this as a group is like, if we want to think about redesigning the baseline function, is that how we should be thinking about the baseline function itself?
I think you're not presenting the importance of why it was chosen to be Kreider's law as accurately. The reason the baseline follows Kreider's law is that when you look at these work networks and what they do, is that the block reward is an impact evaluator that is rewarding work contributed by a community providing resources, and it's untethered from any kind of coordinating system. So that means that it can absorb whatever the entire market can produce, which means that it's going to follow the actual physical improvement rate that all of the market can provide. This is why, for example, the Bitcoin hash rate follows Moore's law. The Bitcoin hash rate is an exponential. Yesterday, we tested this by Vuk. We were looking at this old thing made 6 years ago that told us how much energy Bitcoin used 6 years ago in the Filecoin primer. And Vuk was like, oh, I wonder what it is today. And I was like, oh, it was 6 years ago. It's probably around somewhere between, that's like 3 doublings. It's probably within 100 megawatts? Yeah, per year or something like that. And then we looked it up and it was 130. Exactly. Like, it was super close. These systems are designed to, we have emerged an amazing way to tie the actual capacity of civilization to produce better hardware into an economic model for how to use that to produce a service. which means that if we have the baseline following Kreider's law, we can correctly absorb the right amount of hardware resources into the network to get Filecoin to scale to meet Kreider's law. So you can look at it the other way, which is that the reason Kreider's law hasn't kept up is that the cloud stopped using hard drives as much and moved more to SSDs. And so a lot of the energy and effort put into increasing, reducing the cost there went to SSDs and to flash instead. And people didn't need hard drives to get better, but that improvement rate has moved on to a different disk density. That's still there, and it's still going at about every 13 months or so. And so that's a more fundamental thing than the hard drive curve. And so whatever it is, it should be somewhere between. It shouldn't be 12 months. So arguably it should be 13 months. You could be nicer and call it 14 months, but it should not be 18 months, and it should definitely be an exponential. So anyway.
Yeah, we can certainly get into that in terms of like what the growth rates should be, and yeah, I'm not disagreeing. I think I'm kind of saying like the baseline function right now is based on some law. We can debate whether it's like held up or not in terms of like the media of storage and stuff, but I guess I'm asking the question, and I'll go through this, is like, should we be thinking about the baseline function in terms of physical law that's observed, or should we be thinking about it in a different perspective?
Sorry, that typer. Yes, the baseline is supposed to follow the hardware. It's supposed to follow the capacity of the network to grow, to reduce the cost of providing that same the same proportion of storage density for the world. So the baseline is supposed to, by design, follow the cost density of the hardware.
Okay.
So if you want to change that into a different function, like for example, like the thing that you might allow is to switch it is to tune it to a different storage media, or to have like a more dedicated per storage density law. So instead of having one single law, have a set that follows each storage media. Or you might choose to use QAP instead of RBP, because at the end of the day, QAP still has to follow the actual, it does represent hardware that is there. So you could argue that you could theoretically switch it to QAP without weakening this argument. But it should follow, the KPI of the network should follow the storage density cost decrease. And that's like a fundamental link there, where like that's the role that this is playing. And this can follow, causality doesn't follow in one way. Bitcoin miner hardware has been like meeting the improvement rates, which means that you can have something like Filecoin cause Kreider's law to be met. When the network gets big enough and valuable enough, you can cause this to drive R&D on the hardware itself. Where's Nicola when you need him? This is Nicola calls this how lazy cryptographers improve hardware, which is like you create an incentive structure, you deploy it into the world, and then you cause the R&D to happen to try and extract more and more value faster.
I mean, could you potentially make the argument, and I think Kiran is going to suggest some potential alternatives, and we should give him the space to do that. But hypothetically, in Filecoin land, you could make the argument that the storage density, the hard drive, is a portion of what the storage provider is committing to the network as a part of it. There's also the GPUs that are used to seal things in. Like, there's other aspects to the overall cost, not just storage density. And so you could look at like maybe the aggregated set of costs that come in at different points of the storage provider function. I don't know. I'm trying to posit that there are probably multiple different ways to define the baseline that are not just the storage density, where on Bitcoin's case, it's the, I guess, like GPU/ASIC compute power,
yeah, but
right?
that makes sense, and you could have like a blended cost function, but those other costs aren't changing on an exponential. So, like for example, the labor cost is not getting cheaper on an exponential curve. Like not yet, it isn't. Maybe once we have AGI, it will, but not yet. It is proportional to the raw byte. We agree that it isn't well accounted for, but it is proportional to the actual raw byte power in the picture. You could come up with a different function that takes into account the blended cost, but it's not in an exponential. It's like you could go through a lot of work to do that. It's not going to be that useful because this thing is doubling every year. No, the baseline is doubling every year because storage density is...
We can keep discussing. Yeah, that's the whole point of this, is to discuss.
Yeah, I can be brief. I think maybe one can accept everything that Juan says and then ask the question, okay, there's this should argument, but is it practically useful for the Filecoin network to define its baseline function as this thing, given that it is not, it is not Bitcoin? There are various constraints on the actual commitment of hardware to the network. There are reasons why it might not keep up with that exponential, or not that power on the exponential. And so, is it useful for us to use that function?
Yeah, I think that's kind of the perspective. I wasn't think there's this kind of like idealistic way to look at what we should be doing, and then maybe there's a way to examine the Filecoin specification and see how the baseline impacts different parts of it, and then we can loop back to saying, okay, do we still want this kind of form of the baseline, as in an exponential that's following some physical law? So just briefly, I think everyone here knows about the crypto econ, but I wanted to make a diagram that showed kind of the pathways of how the baseline function impacts different aspects of crypto economics. So this is slightly complicated, so I'll go through this piece by piece. The first pathway is through minting. So the baseline function is a regulator, basically, of how much minting happens on how much Filecoin is minted. It's also dependent on raw byte onboarded, but as raw byte onboarded gets closer to the baseline, you get to the maximum minting rate. That's what this whole equation and the concept of network time is saying. But intuitively, if there's more onboarding, network time approaches real time and we get more minting. And conversely, if there's less onboarding, network time falls below and we get less minting. But the caveat to keep in mind here in terms of incentives also is that more minting does not necessarily mean more fill-on-fill returns. And that's really kind of the incentive structure that a storage provider might use to determine whether to onboard, how much to onboard. So that's the first pathway, is through minting. The second pathway is through pledge. So baseline is very interconnected to all aspects of the crypto econ. So if we look at the equation for the consensus pledge, which is a very large portion of the initial pledge, the baseline functions in the denominator. So it has an impact on the initial pledge, which has an impact on the fill-on-fill returns. There's also a slightly more complicated pathway where the baseline function affects the minting rate, which affects the circulating supply, and the circulating supply affects the initial pledge. And there is a typo here. There's also a locked component here, and sorry about that. There's a typo on the slide. So yeah, so there's basically three different pathways for a baseline to impact fill-on-fill returns. Yeah, so this is the equation. The high level is that if we look at this consensus pledge equation and you look at the denominator, you have this max term. And so what that's saying is that if network QAP is above the baseline, then the consensus pledge is a function of the network size. So as the network grows, as QAP gets larger, pledge gets cheaper. And I think that's kind of like a good thing for the network, right? We want the network to grow.
Also to summarize, I think the total network reward ties to raw byte, but your share of the reward ties to your QAP, and your pledge kind of depends on how much you're expecting to earn too. So therefore, it also ties to your QAP as well.
Currently, QAP is it's meant to encapsulate storage capacity that it now has some useful work done to bring useful data into it. That cost, all of the cost of getting the data and so on, is orthogonal to the storage density question. So you could actually redefine the baseline. This is what I was saying earlier. You could redefine the baseline to be on QAP without changing its role in the network. What it does is that it basically buys you 3 doublings, why 3 doublings? Because it's a 10x multiplier. So that buys you 3 and a bit doublings. And so it just kind of accelerates the time by 3 years in a sense in the network clock, which you could propose doing. The argument for doing something like that would be that this regime is weird, where it's the way that these relationships work, that one is in RBP and one is in QAP, is so weird and messy that it's causing a lot of complexity in people's calculations. And so maybe there's an argument that it should switch to QAP to simplify a lot of that. But that should be well argued.
When you say it, you mean minting?
No, the definition of the baseline,
I see.
which would then cause minting to be
Right.
to follow. Because right now the baseline is just on RBP, but the baseline could be on QAP.
Yeah, I think the point to make here is, looking at the denominator, when QAP is above the baseline, the pledge right now, and I'm kind of talking about the different things that baseline affects, because I think it's a nice segue into the next discussion, but if the QAP is below the baseline, then your pledge decreases, and additionally, it's independent of the network size. But that is also an incentive mechanism to try to get more QAP to onboard again. So it's not necessarily good or bad. This is the incentive structures that are here. So yeah, we've been doing a little bit of discussion, but I think I want to put forward this idea of a potential QAP baseline crossing as a forcing function for thinking about change, not necessarily of the baseline function, but of some aspects of the crypto economics. So this plot we don't need to dive into it. It's just some forecasts that we did, and we're forecasting when we expect the QAP baseline crossing to occur. And that is a good time to rethink how we define these things. So, in terms of, we've been already doing all of this context, but, what is the purpose of the baseline function? It is defining a network KPI, but you can also think about it as a way for the network to modulate the incentives it's like an adaptive modulation scheme for how incentives are distributed in the network. And just things to keep in mind when we're talking about the baseline is if we look at these pathway diagrams, we notice that it's very difficult to consider changes to the baseline without thinking about all the other nodes in the pathways that were shown. So I think the open questions to discuss are if we think about baseline function as an incentive modulator, what should it be incentivizing? Should it be incentivizing onboarding or locking? Noting that increased minting does not equate to increased fill-on-fill returns. Is that something that we want to rethink? Yeah, go ahead.
Could it be that QAP is actually making the current law not work? The QAP is actually, the fact is that we are assuming the same law that we saw in Bitcoin is going to work, but now we have a very different concept, which is verified deals and a QAP that is kind of really having a big impact on it? Could it be that because of that we are not seeing it work? And
I don't think it's just that. I think it's a great question to like figure out like why we're not seeing that behavior. Well, sorry, stepping back for a moment. In Bitcoin's case, it follows it, but with huge oscillations, right? Like you can go look at the hash rate, and it has massive oscillations, like 80% oscillations sometimes, up, 80% oscillations up, usually 50 to 60 down. And so that means like huge amounts of hardware arriving and disappearing. Now, the collateral structure spreads out that effect so that you don't get that magnitude happening very quickly. In Bitcoin's hash rate, it happens like within weeks to months. You have these huge swings. In Filecoin's case, the collaterals widen that and cause it to follow more of like a weighted average. Now, the collaterals are kind of a double-edged sword, though, because they're introducing another barrier. In Bitcoin's case, it's very easy to add hardware. You just plug in a computer and download some software and you walk away. Filecoin doesn't. First of all, Filecoin's pretty hard still. Mining is not as easy as that. You have to know a lot of stuff. And then separate from that, you have to acquire collateral, which is non-trivial. And so there's arguments to doing two things. One is greatly simplifying the storage providing process so that it can be truly as easily as like if you have some spare hardware, you can add it in and contribute to the network. It might not be the most optimal way of doing it, and you might not make the most return, but it should be possible and and easy to do. And the second thing is finding a way to on-ramp you into, by just providing hardware or providing the service, on-ramp you into earning Filecoin to cover the collateral, so you don't have to require upfront capital to acquire the Filecoin in order to do it, because that's a blocker for a lot of parties. I think it's more related to that. If I had to guess, I think it's the bigger barrier is the access to capital than the difficulty. But I think both are huge activation barriers.
actually, we're going back to your point, which is like the second parameter in that equation is actually what's not making us have like SP focusing on revenue, which is kind of also like interacting here. Like that QAP is actually probably having a lot of effect here. But that's super interesting to think about. How do we allow people to do CC without actually earning? And then like if they want to snap that with verified deals, then they need additional liquidity, right? So like I commit capacity only. I do invest some resources. I have like vested rewards that I'm going to get. From the network, I kind of borrowed like liquidity to actually back my sector, but I'm not going to see that anytime soon because I'm just committing now. So I'm able to commit capacity to the network. I'm not paying any liquidity myself. I'm getting like more and more skin in the game because I have more and more vested rewards. And at some point, if I want to amplify that with the deals, then like I snap that, but then like I also figure out a way for me to get liquidity.
Really quickly though, I don't know if it's necessarily the case that like the baseline function is broken if we don't meet it. Because there's also like another framing of the baseline function is just like a target. Like it doesn't have to be the case that we always are on this baseline curve of exponential growth. I think like the other function is just to incentivize cooperative competition to onboard. And because like it doesn't matter if it's 2 fill per month or 1 million fill per month, it's how much that fill is worth to someone to receive, right? So it's like as long as the game is just onboard more for the piece of the pie to get bigger, it doesn't really matter if we follow that baseline like to a T.
I would say one counterpoint to that is that because it's exponential, the longer you don't meet it becomes an impossible target, and then it might become meaningless pretty quickly because it just exponentially grows.
No, because the data in the network is, like the baseline number is still so small relative to the amount of hard drives, or the amount of data storage in the world. Like that would be true if that'll be true when the baseline goes beyond, say, 30% of the hardware capacity in the world, which will happen because we're growing at every year as opposed to every 13 months. But if we were growing every 13 months, then it won't happen.
Yeah, I mean, it just depends on the onboarding rate, right?
No,
and I guess what I'm saying is like,
No, but what I'm trying to say is the onboarding rate is bottlenecked by other things. The hardware exists in the world. Why is it not part of the network?
Is that the reason? But is the bottleneck the reason people aren't onboarding? I think is the question that we're getting at, right?
So in the Bitcoin days, why wouldn't you onboard spare hardware to the network?
Yep.
When it was like easy to, before you needed ASICs and so on. Like today, it's just not worth it anymore. The hash rate is so big that it's just not worth it. Today, like if you have a rack of drives, why not onboard them into Filecoin? A, it's really freaking hard to mine. Like, it's too hard. So you might just not do it, too high activation energy. B, you need a bunch of money to do it, to post a collateral. That sucks. And C, as Einar was pointing out, in addition to that, you have to go do all this other data cap stuff, potentially, to get the QAP. Although I guess not, I mean, you can just do capacity, you start there, and then eventually get to QAP.
Sorry, I was going to say, if you just commit capacity, it becomes even harder to meet the baseline, right? Like, because this equation is comparing against QAP. So, like,
Say it one more time. If you just commit capacity.
Yeah. So I think you're measuring raw byte, if I understood what you were saying correctly, right? And what I'm saying is that the divergence between raw byte and baseline is going to grow even faster. Your hypothesis, I think, is that, hey, if I have raw byte committed and we'll catch up to the baseline. I guess what I'm saying is that as time accelerates, it becomes harder and harder to meet it just because of the growth rate.
No, I understand that, but I'm saying as long as it's not the actual value of the baseline isn't more than like 30% of the total available storage on the planet, then we can meet it. We just have to figure out how to enable that storage to come into the network. Why 30%? Because arguably 70% of storage could be doing some other stuff. We could set an ambitious target and call it 80%, but that's getting more aggressive. But until that number isn't larger than that, we can absolutely meet it. It's just a matter of figuring out these other barriers. Those are the things that are withholding that amount of resources coming into the network. And my sense is the biggest one is the collateral cost. The QAP question, the data cap question is kind of like a dominant strategy analysis that we should figure out. Whereas, like, does it make sense if you can't reasonably get data cap easily? Does it make sense for you to bring capacity into the network?
Let's continue the conversation in that open area, maybe.